Ungrouped frequency distribution means ungrouped frequency distribution means, as I told you, we have lot of observation, but the range of data is small. What is range of data? The minimum value or minimum observation, the difference between the maximum value and the minimum value. Go to page number 224. Look at the first set of data given to you. You can see there are plenty of observations given. There are 19 observations given to you, right? Is it 19? 1, 2, 3, 4, 5, 6, 7. Yeah, 19 observations are given to you. But look at the range. Range in the sense, what is the smallest observation you see there? Which is the smallest observation? Go to page number 3, correct. Which is the biggest or the largest observation?
6.
6. So when you see 6 minus 3 is just 3, right? So when this kind of, when the range of data is very small, you have to go with ungrouped frequency distribution. That means each and every observation you have to write and put the tally mark against. So first observation is 3, then 4, then probably 5, and then 6. Okay, now you see here, there are only 4 observations. Now you just do the tally mark here, how many times each of the observations have come up, and then just write the frequency. Understood? Here you write the frequency, here you write the tally mark. Can you quickly do this? Can you do the, this is the shoe size of many kids. So write size here, tally mark here. Can you check page number 224? First question, just finish it off. Okay, I'm just coming, someone is at the door. So how many times 3 is coming? 4 times, right? 3 is repeated 4 times. 4 is repeated some 3 times. 5 is 1, 2, 3.
4 times.
Yeah, 4 times. And 6 is the max, it seems. Yeah. 8 times. And after calculating, after putting these numbers, say 4, 3, 4, 8, you need to add them. Add the frequency and see, are you getting 19 or not? Got it? So you have to double check whether you have missed to mark any frequency. So make sure you do that and then put the frequency as 19. Okay. Okay, now next is grouped frequency distribution. So what is group? This was ungrouped because the range of data, range means maximum observation, the size of the first biggest observation minus size of the smallest observation, difference is small. Then you go for ungrouped frequency distribution. Next is grouped frequency distribution. Grouped frequency distribution, what you do? In grouped frequency distribution, you sometimes in the question itself, they will say do grouped frequency distribution. Then you don't need to think, you don't need to calculate the range and all that. Just go with grouped frequency distribution. They will tell you how to form the group. So what here, the class intervals they have mentioned, I'm talking about question number 1 in page number 224. They have clearly mentioned the class interval has to be, we are talking about 32 students mark, and the heading then comes as marks. Then how should it be? For 1 to 10, then comes 11 to 20, then so 21 to 30, 31 to 40. What is the maximum mark observed? I think that's it. Maximum is 40 included. That's it. So you don't need to make anything further. 40 should be good enough. Now write the do the tally mark column, and the last one is frequency column. Got it? And after calculating all that, you should have, add up and see whether you are getting 32 here. You have to add up the frequency and see, are you getting 32 or not? If not, go and check again. Okay, so 1 to 10, I want you guys to quickly do the marking here. Look at the class interval. 1 to 10. It's not continuous interval. Continuous interval means if it is continuous interval, it will be 1 to 10, 10 to 20. The upper limit of the one class and the lower limit of subsequent class will be same if it is continuous interval. But this is not continuous interval because it is 1 to 10. Then the next class is 11 to 20. If sum of the observation is 10.5, where will you put? Then you will be in trouble. Understood? But here they have not given anything like 10.5 or 20.5. So you can, there is nothing to worry. You can just put the tally mark and then proceed. Okay. So 29 will come against this. 23 will come against this. 30 will come against, no, I went wrong. 31, 30, right? 30 is here. 40 is here. 11 is here. 1 is here. 15 is here. 35 is here. Then 40 again here. 3 here. 12 here. 18 cut like this. 30 here. 24 again here. 25 cut. Put 4 tally mark and fifth one is cutting. 29 here. 31 here. 32 cut. 25 again right here. 22 again here. 27 again here. 12 is here. 13 here. 2 comes here. 7 again comes here. 9 cut. 19 here. 13 here. 32 is here. 39 is again here. 25 is here. 3 is here. Okay, so let's see whether I got the correct observation. This is 6. This is 5 plus 4 is 9. Here it is 10. Here it is 5 plus 2, 7. So one observation, I think I have gone wrong. 1 or 2 observation. Okay, somewhere I have gone wrong here. 11 to 20, I went wrong. So 11 to 20 is 11 ones. Let me just count it. 1, 2, 3, 4, 5, 6, 7, 8. Only 8 observation. Only
you
8
put an extra for 11 and 1 less for 21 to 30.
That's true. That's what happened. So it is when I counted it, I am getting only 8 observations. So like that, you can count and see. Okay. So between 21 and 30 that I did not count. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 9, 10. I'm getting only 10 observation between 21 and 30. 1, 2, oh, 30 is included. 1, 2, 3. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. Still, I'm getting 10 observations. Did you all get about 11 observations?
Mom, I got 11.
2, 3. Oh, 1 minute. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes, I did not count 30. That's what happened. The 30, I counted once. The second time I did not count 30 there. Okay, so now add up 10 plus 16 is 16. 16 plus 9 is 19 plus 6 is 25. 25 plus 7 is 32. Yeah, so 32 observations I got. Yes. Now let's do given below are the marks obtained by 24 students in an examination, taking class intervals as 10, 20, 20, 30. Okay, now this is going to be continuous classes. Okay, so what we did previously was not continuous. I told you that if the problem will happen when you have observations like 10.5 or 10.75 like that, then you will not be able to mark in this table. Okay, in this frequency distribution. If continuous frequency distribution is considered, then it will be like 10 to 20, then 20 to 30, 30 to 40. So here what happens is up to 20, not including 20, say up to 19.99, whatever comes, that will be included in this class. Anything above 20 to 29.9999 will be included in this class. Are you all understanding? Any questions
Yes,
here? That's
No.
how, yeah, that's how continuous data, continuous interval works. Okay. So this question, the second one is in that you have continuous interval. So the class interval, I mean, continuous interval means class interval is continuous here. So because 10 to 20, 20 to 30, like that, you have to mark up to 50 to 60. Do we need to do, or you all understood this? Can we proceed? So when 40 comes, will you, okay, tell me, when 40, observation 40 comes, where will you include? I'll call out a name. Vidat, you tell me, when 40 comes, where will I include 40? In which class interval I will include 40? In this or in this? Where will I include 40?
Ma'am, in the second one.
Yeah, here, right?
40 to 50.
40 to 50, that's right. So this you all have to remember. Now, if it is, say, 10, if I'm saying 10, where will you include? Do you have the class interval here I have shown where you can
1
include
to
10?
10. I mean, 10 to 20, sorry.
10 will be included under 10 to, no.
Yeah.
10, I said 10, right? So 10 to 20, yes, you will be including
yeah,
10 under 10 to 20. Got it? That's all.
Yes, ma'am.
Okay, now can we move on to types of frequency distribution? There are, I think this tally mark and making a frequency distribution, you are all clear with. Let's move on to types of frequency distribution. Types of frequency distribution. What is that? So there are two types of frequency distribution. One is called inclusive and the other is called exclusive. This we have already discussed. Inclusive and exclusive. You have inclusive distribution and exclusive distribution. Okay, so in inclusive distribution, what happens is the upper limit of one class does not coincide with the lower limit of the next class. Basically, I said continuous, right? I said continuous interval. So inclusive distribution is non-continuous interval. Understood? Inclusive means you just think of it as non-continuous. Non-continuous means your class interval is going to be 0 to 9, 10 to 19, 20 to 29, like that. This is how inclusive distribution looks like. Okay, so the definition here is the upper limit of one class does not coincide with the lower limit of the next class. Got it? Understood, right? Any
Yes,
questions? Yeah, that is inclusive. Do you want me to write down so that you can note it down, or you will learn from the textbook? What do you want to do?
The textbook.
So or take example here. Then after this, write example as 0 to 9, 10 to 11. Sorry, 10 to 19 and 20 to 29. I just write the example so you will understand what is meant by inclusive distribution. So exclusive distribution is which one? The continuous one. So here what you will do, it's the upper limit of one class coincide with the lower limit of the next class. So here 10 to 20, 20 to 30, 30 to 40 will be the example. So basically here what happens is this class will include 10 less than or equal to x less than 20. Anything less than 20. If 20 or bigger numbers come, it will come under this class. X is the observation. Consider X as the observation. Okay. So in this case, X is your observation, where you will put it in against which class interval you will put 20. It will be where 20 is coming as the lower limit. You won't put that entry against when 20 is coming as the upper limit. Okay. So in this kind of, if you want to denote inclusive distribution like this, it will be 10 less than or equal to X less than or equal to 20. Okay. So 10 less than or equal to X less than or equal to 20, because 20 also will come in that class. If I am writing it is, okay. If the class interval was 10 to 20, and this will be, it will be 11. Okay. It should be actually like that. 11 to 20. You don't write it as, yeah, you don't write it as 10. Okay, 11 less than or equal to X less than or equal to 20, 21. This is 11, 21 to 30. So 11 less than or equal to X less than or equal to 20. That's how you will write the inclusive distribution. Here, this is less than or equal to, this is also less than or equal to. Whereas here, it will be less than or equal to, but here it is just less than. 20 is not included in that class. In that class interval, not class, that class interval. Okay. So most of your problems, like you will be learning to draw histogram or frequency. Some histogram you will learn, then frequency polygon you will learn. So in all these things, you should be converting it into a continuous class interval. Okay. Or if I use the type of frequency distribution term, you prefer to use as exclusive distribution. You don't use inclusive distribution. So you should know how can you convert an inclusive distribution into a exclusive distribution. Okay, so that's the next thing that you're going to learn. So here I'll give you an example. You have, say, classes. Here what they have mentioned is class or marks before adjustment. Before adjustment means that is inclusive distribution. So 1 to 10, 11 to 20, 21 to 30, 31 to 40. Okay, so this is before adjustment. Now you have after adjustment. After adjustment means you are going to make it exclusive distribution. So this is exclusive. This is inclusive. How do you do it? You have to look for this. What is this? Lower limit of one class, and you have upper limit of the next class. Find the difference between these two and divide by 2. What do you get? So you have to calculate an adjustment factor. Adjustment factor is, what is that? Upper limit of subsequent class. I don't know what to write. You write it the way you understand. Okay, upper limit of subsequent class or next class minus lower limit of current class or current class divided by 2. In this case, you have 11 minus 10 by 2, which is 0.5. 1 by 2 is 0.5. Okay, so all of you understood what I did here? What is the adjustment factor? Adjustment factor calculation is clear. Upper limit of subsequent class minus lower limit of the current class divided by 2. That factor, that adjustment factor, you just add that factor to the upper. Wait. What did I do? I have written wrongly. Okay, just a moment. What did I do? Upper limit of it's actually lower limit of subsequent. I'm really sorry. It is lower limit of subsequent class minus upper limit of current class. Upper limit of, I'm sorry. It is upper limit of current class. That's what you need to do. Lower limit of subsequent class, because 11 is coming in the lower limit place. I'm really sorry that I confused you. So this is lower limit of subsequent class, and this is upper limit of the current class. Clear? And to the lower limit of each class, you subtract the adjustment factor. So 1 minus 0.5 would be 0.5. And to the upper limit, you add that adjustment factor. So 10 plus 0.5. Again, your next class is 11. Lower, always lower limit minus adjustment factor. So it would be 10.5. To upper limit, you have to add the adjustment factor. It is going to be 20.5. This process continues. Lower limit minus adjustment factor, upper limit plus adjustment factor. Understood? Class size. What is meant by class size? Class size is, what is a class size? You just lower limit minus upper limit. Sorry, upper limit minus lower limit. Upper limit minus lower limit. What is that? Whatever it is. If it is 10 to 20 or 20 to 30, maybe 20 minus 10, which is 10 would be the class size. Understood? Class size is upper limit minus lower limit, or the difference between the upper limit and lower limit is called class size. Then the next thing is called class mark. This class size and class mark is a important concept. You should know what does that mean. Class mark means midpoint of the class size, or I should not say class size. Any class you take, any class interval you take, its mid value. So class mark of, say if I say class mark of 10 to 20. This class mark of the class 10 to 20, the interval 10 to 20 would be 10 plus 20 by 2. What is that? 30 by 2, which is 15. So class mark is, yeah. So class mark is this. Okay. So if the class mark of, if you want to find class mark of 11 to 20, what would be that? 11 plus 20 by 2, which is 31 by 2. Okay, 31 by 2 is 13.5. Got it? So midpoint, you can think of as a midpoint here. So 11 plus, depending on the class interval or concept, and then you can pick up some exercise and start doing it. So next point is about cumulative frequency and cumulative frequency table. This is very important because when you are learning about median, you might, not this year, in 10th grade, you have to draw median in a graph. You have to calculate median from a graph. So you need to know cumulative frequency. Only then you will be able to calculate that. We have something called ogives and all that. All that requires cumulative frequency calculation. So what is this cumulative frequency? It's a very simple, easy thing. So you will be given one frequency distribution table like this. So marks, frequency. This is how it will be given to you. And what is marks? Marks is in the range 10 to 20, 20 to 30. See, this is an exclusive distribution. Okay, remember, this is an exclusive distribution because lower limit and upper limit are same. So that's how it becomes exclusive distribution. 10 to 20, 20 to 30, 30 to 40, and 40 to 50. Now, what is the frequency? Frequency is 4, 9, 5, and 6. This is the question. Now, they are asking you to calculate the cumulative or make a cumulative frequency distribution. Okay, or find cumulative frequency. So here, what you will do, you will write here. This is the question. Okay, the marks and frequency will be given to you and ask you to calculate cumulative frequency. So what you will do, you will add one more column and write cumulative frequency. And you are doing cumulative frequency column. What is it that you're doing? In the first column, from 10 to 20, what is the frequency? 4. Okay. Now the next thinking process is up to, starting from 10 to 30, what is the frequency? Starting from 10 to 30, okay, what is the frequency? If you're starting to count, if the range is from 10 to 30, what would be the frequency? (10 to 30). I'm not talking about 20 to 30. I'm talking about if it was from 10 to 30, what would have been the frequency? You just need to add, no, 4 plus 9. Just do 4 plus 9. What is it? 13. Are you not understanding? Hello? Hello? Tell me what would be up to 30 to 40. Starting from 10 to 40, how many observations would be there? Starting from 10 to 40, how many observations would be there? If I am starting from 10 to 50, how many observations are there? To 18, I just need to add 6, which would give me 24. So what is the cumulative frequency? Cumulative frequency is writing like this. If I write one table, cumulative frequency table, it is just like this. Cumulative frequency. Okay. This is 10 to 20, 20 to 30, 30 to 40, 40 to 50. And this is going to be 4, 13, 18, and 24. This is the cumulative frequency distribution table. Okay, marks and cumulative frequency. Got it? So both this and this, both are correct. You can represent, you can do in whichever way you want. Page number 228. Okay, page 228, 9th exercise. Here, they have given you a frequency distribution. They have given you a distribution. Now they are asking you to calculate, take the second one. Okay, second question. They have given a class interval. They have given cumulative frequency. So class interval is given, cumulative frequency is given. What is the class interval? 5 to 10, 18, 10 to 15, 30, then 15 to 20 is 46. Next is 20 to 25 is 73. 25 to 30 is 90. So 18, 30, 46, 73, 90. So this is what is given to you. Now you need to calculate. You need to find the, which one? Frequency distribution table. Frequency distribution means you just want cumulative, class interval and frequency. That's it. So this is the table that you want. Okay. So what will be against 5 to 10? What is the value? First entry will always the same thing. It is not cumulative. It will continue to be 18 itself, because you are talking about up to 10. How many observations are there? 18. Now the next onwards, it is like starting from 5 to 15. How many observations are there? Okay. So 5 to 15, there are 30 observations. 5 to 50, there are 30 observations. We don't want to write cumulative frequency here. What you want is just the normal frequency distribution. So in between 10 to 15, how many observations are there? 30 minus 18. It is going to be 30 minus 18. What is 30 minus 18? What is that? You calculate and tell me.
12.
12.
12.
Yes. Next is 15 to 20. In 15 to 20, what is the given as 46. So 46 minus 30. Okay, so you are just doing this minus this. When you do the 46 minus 30, what is the observation? That is 16. Similarly, 20 to 25, it is 73 minus 46. 73 minus 46, what is it? 56, 66, 26, right? No, 27, I believe. Yeah, just tell me it is 27 or what? Is it 27? 90 minus 73 would be 17.
I'm 17.
Yes. So this is the table. And what is the frequency? You can calculate the frequency. How do you calculate the frequency? Just add up 18, 12, 16, 27, and 17. So when you add, how much you should get? You should get 90. Okay, 90. Because here, what is the highest, the cumulative frequency that you got? That will be the frequency. So just add up and see whether you are getting that number. Yes, I'm getting that answer. So this is the frequency distribution table. Okay. Just check whether you got this answer or not. So basically, if you want to write a cumulative frequency distribution, just write a class interval and cumulative frequency. And just write 0, 8 is 9, 8 to 16 is 22, then 16 to 24 is 34, 24 to 32 is 41, and 32 to 40 is 56. So this is going to be your cumulative frequency distribution table. Okay. If they have given inclusive class interval, and if they are asking you to calculate cumulative frequency, you don't need to change the class interval. Okay, you don't need to do bring in the adjustment factor and do the changes. No, you don't need to do it. When the question is find the cumulative frequency, just add up and come up with the cumulative frequency. That's all. Don't make any changes. Say, for example, this was like 8 to 9, 9 to say 16. If that was the case, then don't do any changes to your class interval. Just do the required changes at the cumulative frequency side only. Okay. I hope you're clear with what I'm saying. Don't do any changes at the class interval thinking that, oh, this is not continuous or this is inclusive. We have to write exclusive distribution. No, If they ask you to convert into exclusive distribution, at that time you do the exclusive distribution. Otherwise, when you do the histogram and all that, at that time you will have to do. That is for graphical representation. That is different. Don't mix it with calculating cumulative frequency or changing it from cumulative frequency back to frequency. There, you don't need to touch your class interval. Okay. Any questions?
No, ma'am.
Okay. Let's wind up then.